So in section 5.2, we're going to continue to work with our rules for exponents. We're actually going to add a few rules to the ones we already know. So filling in these, when we multiply things with the same base, what happens to their exponents? Add them together. Good. N plus m. Power to a power, multiply n times m, and then subtract. Good. N minus m. So those are the review ones. Here's the two new ones we're going to pick up this section. A to the negative n and a to the 0. We're going to start with the latter of these two to try and figure out what they mean. Starting with a to the 0, I'm going to see if we can't try and convince ourselves of what something to the 0 power looks like. Let's do it this way. Let's start out with this, a to the 5th over a to the 5th. And what I'm going to do is I'm going to use my quotient rule on this. That is this one over here. When I have something divided by something else, I subtract their exponents. So 5 minus 5 gives me a to the 0. Now that's kind of a brute force approach on this. What if I took a more simplistic look at this and said, oh, well, I'm dividing something by itself. What do you get when you divide something by itself? 1. So there you go. A to the 0 power is 1. So that's one of the new rules we're going to learn in this section. Then we'll practice it some more with some work in the next section. Actually, we'll practice negative exponents more than 0 exponents. But we'll start with problem number 14. 9 to the 0 power. 16 is 3/8 to the 0 power. And then 18 we're going to have to think about a little bit. 8t to the 0 power. So the idea is to use this new rule. Can anyone start out by telling me problem number 14? 1. Sure. Something to the 0 power is 1. Cool. Preston, how about the next one? Well, let's go with the rule here. When you have something to the 0 power, anything to the 0 power is 1. So 3/8 to the 0 power is still 1. In fact, maybe you guys would be a little more comfortable with it if you saw it on your calculator. Take out your calculators. Pick your favorite number. I'm going to do 2. 2 is my favorite number. 2 to the 0 power gives me 1. Okay. Anything to the 0 power gives you 1. But that doesn't mean that your answer to all these 0 exponent problems is going to be 1 all the time. Case in point is problem number 18. Now it's true that anything to the 0 power is 1, but is the answer here 1? No. What should it be? Good, because t is just the 0 power, so it's 8 times 1, which is 8. Now what you could be getting confused with is 8t to the 0 power. What if I had the whole thing in parentheses to the 0 power? What would I get here? 1. Now I get a 1 because that 0 applies to everything here. Here it only applies to the t. T to the 0 power is 1 times 8. So there's a subtle difference between these two. I tend to like to put two problems like this next to each other on an exam, just to see if you understand the difference. So if there's some confusion, let's talk about it now. 8t, what, for this one? Or first one or second one? Right. But it's not t to the first power. It'd be t to the 0 power, and that's 1. Anything to the 0 power is 1. So t to the 0 gets replaced by 1, not t. That's different than t to the first power, or just t. So, good question. If that was a 1, then yeah, I'd have 8t. Anything else on this one? Good. So you're ready for this one? You've got warning. I'm not trying to trick you. I'm just trying to see if you understand the difference there. Let's try and figure out our other rule. And I'm going to do that by example. Suppose I had a cubed over a to the 5th. Well, a cubed is a multiplied by itself 3 times. And likewise with a to the 5th is a multiplied by itself 5 times. Now if you write these out, if you expand them, then you'll notice that you can actually do some cancellation, some simplification. Now let's understand what's happening when I cancel here. A divides into A once, and into A once again. I can cancel this one as well. A divides into A once, and into A once. And I can do one more here. A 1 and a 1. What am I left with? 1 over a squared, right? 1 times 1 times 1 over a squared. But what if I did it another way? Let's go back to our quotient rule for these exponents. I get a to the 3 minus 5. What's 3 minus 5? Negative 2. So that's kind of an interesting conclusion here. A to the negative 2 is the same as 1 over a squared. In other words, when you have a term with a negative exponent, you can get rid of that negative exponent by taking its reciprocal. So I'll put 1 over that term with a positive exponent. Let's fill this in now. Kind of completes our rules for exponents. This is 1 over a to the n. So that's the other one that we're going to spend some time on today. Is right here. Yes, sir.
So you can never get a negative power.
Say again?
So you can never get a negative power.
Or you can have, there's nothing wrong with negative power. It just means, 1 over a to the n. So, for instance, let's take a look at problem number 72. Or 20, not 72, talk about 22. 7 to the negative 2nd power. To get rid of that negative exponent, what I would do is write that as 1 over 7 squared, which is 1/49th. Now for giggles, I'll also do that on my calculator. So 7 raised to the negative 2nd power. And if I compare that to 1 divided by 49, I get the same thing. So, yeah, there's nothing wrong with a negative exponent. Although, generally, on your exams in this course, I'm going to ask that you not use negative exponents. I want positive exponents. And it's just to make you practice these rules here. The exception to that is going to be in section 5.3 where we work with scientific notation. But other than that, I'll always be asking for positive exponents. Let's take a look at problem number 26, c to the negative 4, and problem number 28, negative 8 to the negative 1st power. And the goal is to write both of these with positive exponents. Carrie, how about the first one? What's that going to look like? Carly, sorry. 1 over c to the 4th power. Good. Madison, up front. How about the second one? Good. 1 over negative 8. You don't have to write to the 1st power. You can if you want. There's 2 ways I'm going to rewrite this. First of all, I'm going to get rid of the parentheses into the 1st power. I don't need that. And secondly, I'm going to put the negative out front, which is more like what you're going to see in an answer book. They're not going to leave the negative here. If you wrote the negative here, I'm not going to mark you wrong. But chances are, in any answer key you're going to look at, you're going to see one of these two as the final answer. The negative out front or in the numerator. Math books are not going to leave the negative in the denominator. It just doesn't look right. All right. Thank you, ladies. Let's try a couple more here. I'm going to do problem number 30, and I'll give you a chance to do problem number 32. So we'll start with 30, which is negative 9 to the negative first power plus 9 to the negative second power. So, question for you. Does this negative exponent apply to the 9 or the negative 9? Which one does it apply to? Just the 9? Okay, just the 9. So the negative just kind of stays out in front. And 9 to the negative first power is 1 over 9 to the first power. How about the second one of these? How can I rewrite that one? 1 over 9 squared. What's 9 squared? 81. Now to add these together, what do I need? Common denominator. Common denominator for these would be what? 81. So to get that common denominator, I'll multiply here by 9 over 9. Effectively, I'm multiplying by 1. So that gives me negative 9 over 81 plus 1 over 81 for a total of negative 8 over 81. One of the important things to see here is that this negative exponent only applied to the 9, not to the negative. And that's going to be a subtle but important difference in a lot of these problems. So, are we okay with problem 30 there? Because I want you to do one that's pretty similar to that one coming up now. Problem 32. 7 to the negative first power minus 7 to the 0 power. So see if you can't simplify that one. I'm going to walk around and help out a little bit, check on how you're doing. It's going to be much the same way as the last one. Rewrite it, get common denominators, and then keep going from there. Okay, so 7 to the negative first power is 1 over 7. 7 to the 0 power is 1. Now, in order to subtract these things, I need to write them with a common denominator. So I'll think of 1 as being 7 over 7. And now I can subtract the numerators. I'm left with negative 6/7. So let's do some more here. Problem number 36. I'll actually go back and do this in a comparable way in just a second. But the problem itself starts out as 27m to the negative third. Okay. So 27m to the negative third. You could think of that, and our goal here, by the way, is to write this with positive exponents. So one way to do that is to think of that as 27 times 1 over m cubed. Or better yet, just 27 over m cubed. Now what happens when you're working with these negative exponents is that these terms are going to kind of switch sides. Now I know that there really wasn't a denominator in this problem, but if you wanted to think of it as dividing by 1, that term is going to come down to the denominator. And when it switches sides, it's going to switch signs in the exponent. Now something that's easy to confuse this with would be something like this, 27m, let's see, 27m to the negative third like this. That's a whole different animal. In this case, the whole thing comes down to the denominator. It'd be 1 over 27m cubed. And from there, you can cube out both of these. So 27 cubed is 19,683. And then the m also gets cubed. So they're much different things. And what I want to draw your attention to and what I'll quiz you on is, do you understand what's the base of this exponent? Is it just the m, or is it both of those terms? And clearly it makes a big difference. Okay, problem number 40. Let me give you an expanded version of problem number 40, kind of testing you along these lines. So here's problem number 40 as it is in the book, negative 4 to the negative second. Let's also throw in negative 4 to the negative second. Typically, when I do these things, and I'm not promising anything, but typically the answers are different. I'm trying to see if you understand the difference in these two problems. Okay, so in this first one, the base of this exponent is just the 4. So the negative stays out in front. It's 1 over 4 squared, which is negative 1 over 16. Now the big difference between this one and this one is that the base of this exponent is the whole thing. It's negative 4. So 1 over negative 4 squared. When I square negative 4, I get a positive 16. Perfect. This is a great example of being careful where the exponents apply. We're okay with problem 40 there. Let's try problem number 46. Seven to the negative 2 over 2 to the negative third. Now maybe you just want to sit back for a minute and watch and kind of catch the happy ending, the result here that I get. I'm going to take a little bit longer path than I suggest you take typically, just for this first one. 7 to the negative second. Judy, how could I rewrite that one, please? Good. 1 over 7 to the second power. And then likewise, 1 over 2 to the third power. Now when you divide things when you're dividing fractions, what's the rule for dividing fractions? One over 7 squared. Then what? Anyone? Times the reciprocal, right? 2 cubed over 1. Now I'm not worried about the 2 cubed is 8 or the 7 squared is 49 here. What I wanted to get to is this. Can anyone suggest a shortcut when you're looking at stuff like this? What's the shortcut to go from here to here? Yeah. Switch sides and switch signs, right? So this comes down here, it becomes a positive exponent. This goes up into the numerator, and again becomes a positive exponent. So it's a nice little negative exponent shortcut there for you on problems like this. So let me give you a chance to apply that. Problem number 48. Negative 9 m to the negative first power over n to the negative 30th. Let me help you out by writing the negative 9 out in front. Negative 9 does not count as something with a negative exponent. You're not going to flip that. We're just going to leave the negative 9 where it is. What I want you to worry about is the rest of the stuff. Madeline, how does this simplify, or how could I rewrite it? So what would I get? Yeah, just m to the first power, or just better yet, just m. Perfect. So these terms, when they switch sides, they also switch signs. So this came up to the numerator, it became a positive exponent. The other one went down to the denominator, and again became a positive exponent, even though we didn't necessarily write it. So good job. Now, I am going to show you another shortcut. You don't necessarily have to use these. There's other ways to do these problems, but they're helpful. So if you catch some of these, great. If you don't, it's all right. You're not going to be in a world of hurt. Now the shortcut that I would share with you here, and I'm not going to spend as much time really proving it, is this. If you've got a negative exponent on the outside like this, and a fraction on the inside, you can do two things. So it would be x over a, but this time, instead of negative 10, what am I going to have? Positive 10. So that gives me x to the 10th over a to the 10th. Yay. Now, what if you're not comfortable with that? You're like, I know I'm going to get confused, especially if one of these has a negative exponent. I'm really going to get lost. That's okay. If you're not comfortable with that, then keep in mind this. Each of these has an exponent of 1. So if I remove the parentheses, then I'll get negative 10 times 1 is a to the negative 10th over x to the negative 10th. And from there, we can use our trick from the last two problems. Is just switch them, right? This goes up to the numerator, positive exponent. This comes down to the denominator, positive exponent. So different way to work it. Pick a way that you're comfortable with. Now, like the last trick, I'm going to give you a chance to use this one. So 2 over t to the 4th, excuse me, 2 over t to the negative 4th. See if you can't simplify that one much the same way that we did problem 54. Write your final answer with positive exponents. Yes, negative 4. Shane, how can we start out? What did you do to start? Good. T over 2 to the 4th. Nice. Does it simplify from there? All right. Keep going then. All right. 2 to the 4th is what power? Is what? 16. Yeah. On this one, I'd be happiest to see t to the 4th over 16. So, if you wrote t to the 4th over 2 to the 4th, well, you kind of should simplify it there, but I'm not worried about that as much as I am you getting the rest of the work with exponents correct. Let me do problem number 58, and then I'll give you 3 in a row to try. Problem 58. Couple ways you can do 58. It's m to the 10th times m to the negative 6. One way to do this is to practice our rules for exponents. In this way, m to the 10th times 1 over m to the 6. I'll think of that as 10 over m to the 10th over 1 times 1 over m to the 6. Better yet, m to the 10th over m to the 6th. Now I've come a long ways just to use my little quotient rule for exponents. M to the 10th divided by m to the 6th. How does that simplify? M to the 4th. Good, you subtract the exponents. But there's another way I could have done that. Back up here, when you multiply things with the same base, what happens with their exponents? Add them. So what's 10 plus negative 6? M to the 4th. I like that. The one thing that's tricky in working with exponents is that there's no order of operations. You don't have to do one thing before another unless you have parentheses, but in general you're kind of free to do it in any order that you want. So pick something that's comfortable to you. Now, as promised, I'm going to give you 3 different problems to work on. You can help each other out. I'll walk around and try and help you out as well. We'll start with problem number 60. C to the negative 9th times C to the 14th. Then problem 64. Y to the negative 3rd over Y to the positive 4th. Keep an eye on this one. A lot of people wanted to put a negative here or treat it as if there was a negative here. It's a positive 4 is the exponent of y in the denominator. Last but not least, problem number 68, n cubed raised to the negative fifth. All right. Help each other out. Like I said, I will walk around and try and help you out as well. Write your final answers with positive exponents.
Their notes.
I'm trusting you. I suggest you get rid of the negative exponent first. Just get rid of the negative exponent. Invert multiply, you'd have 1 over y to the fourth. I'm afraid these are all right. Okay, so with the first one, I would suggest you just multiply these together by adding their exponents. Negative 9 plus 14 gives you c to the fifth. Done. I mean, you can do it in other ways, but I think that's the most efficient way. I think I'm going to take a few extra seconds and show you a bunch of different versions. Because walking around, I had a few in mind, but there's probably a lot of ways you could do problem 64. So the way I think of first is to get rid of the negative exponent in the numerator. Now notice there's no exponent, negative exponent in the denominator. It's just the numerator term that's going to come to the denominator. So that's 1 over y to the fourth times y to the positive third, which is 1 over y to the 7th. Add their exponents. So that's one way. Let's see about some other ways. So we'll call this A. Let's do a different one. What if I subtracted exponents here? Could I do that? Yeah, you're dividing things with the same base, so it'd be negative 3 minus 4 gives you y to the negative 7th, which is, oh, that's 1 over y to the 7th. So that's a different way. So call that one B. Some of you liked the reciprocal idea. So you said, all right, well, that's 1 over y cubed divided by y to the 4th. If you're careful, you can make this one work as well. Y to the 4th in the denominator is really y to the 4th over 1. So if I'm dividing by a fraction, I got to multiply by the reciprocal. Y to the 3rd times y to the 4th gives you 1 over y to the 7th. All right, so I just want to see kind of a show of hands here. Which way did you like best? A. All right. 3, 4 of you. All right, so 4 for A. How about B? All right, 2, 4, 6, 8, 9. 9 for B. So, yeah, 1, 2, 3, 4, and then 5. All right, actually, I think the right way to write that is IX. Anyways, C, last one. How do I like that one the best? All right, 1. I know it was at least one other person. So we'll do 2. And we'll put an option D. Prefer not to do it. D? All right, everybody, a lot unanimous on D. Okay, like I said, there's a lot of variety in how you work on these things. You're just going to have to, I don't want to say a bad word, but you're going to have to practice, which means do your homework. Problem number 88. Negative 9 to the negative 2nd. Say again? Oh, did I do not? Oh, yeah, I forgot 68. Yeah, thank you. So let's go back here, finish up 68, and then we'll do 88. Here, the exponents multiply. So 3 times negative 5 is negative 15. 1 over n to the 15th power. Thanks, Nick. Let's try problem number 88 and yeah, let's do 88 first together, and then I'll let you do a couple. What's the base of this? Is it negative 9 or just 9? Negative 9. So the whole thing, negative 9, is going to come into the denominator as something squared. And when I square that out, I get 1 over 81. Okay. Your turn for a couple. Problem number 96 and 102. 96 is p cubed over 2. P cubed over 2 raised to the negative 2nd power. Problem number 102 is y to the negative 2nd times y to the negative 2nd. So why don't you give those a quick go. Remember, the goal is to write these with positive exponents, and that is a negative 2 up here. Okay, so with the first one, what I would encourage you to do is take the reciprocal of what's inside and make the exponent on the outside positive. So that gives you 2 over p cubed raised to the positive second power. Well, I want us to keep going though, right? Because what's 2 squared? 2 squared is 4. Do these exponents multiply or do they add? Multiply. 4 over p to the 6th. That's what I wanted. Okay? How about the other one? Couple different ways you could do this one. Did anyone do it this way? Add exponents, get y to the negative 4th, and said, all right, that's 1 over y to the 4th. If you ever do it that way, okay. Did the rest of you do this? Say, all right, that's 1 over y squared times 1 over y squared. Add the exponents, get y to the 4th. The rest of you do it that way? Okay. Both of them are fine. And it's, again, a matter of what you see. As long as you're using the rules that I outlined at the start of this section, you should be in good shape. We keep on working with those negative exponents. Let's try problem number 110, and then we'll back up to problem number 108. So problem number 110 looks like this: 9s to the negative 6 squared. Well, it's, there's a couple ways to look at this one and think about it and do it. One thing that is useful to keep in mind is that even though it's not written, there's an exponent for the 9. What's the exponent for the 9? It's a 1. Now, the exponent on the outside does what to the exponents on the inside? Multiplies. So this is going to be 9 squared s to the negative 12. A lot of times people forget to square out that 9. 9 squared, of course, is 81. Don't leave it as s to the negative 12. How can I write this? Yeah, I'd write it as over s squared. I mean, the step in between here really is 81 times 1 over s to the 12th. But that just leads to this anyways. 81 over s to the 12th. So the idea, again, is that when you have these negative exponents, it switches sides of the fraction. And an example on steroids of that is problem number 108. 5 to the negative first power times x to the negative second power times y to the negative third power over 8 to the negative second power x to the negative first power. No, the negative 11th power. Pardon me. X to the negative 11th power. Let's work our way through this one together. What I would strongly suggest in simplifying these things is that we first clean up all these negative exponents. So I'll start it here with y cubed. Y to the negative third power. That term is going to come down into the denominator as y to the positive third. We're going to get some more changes as well. 5 to the negative first power. That's going to come down in the denominator as well. It's going to be 5 to the positive first. X to the negative second. That comes down to the denominator as x to the positive second. So all these terms are switching sides to get rid of the negatives in their exponents. But we should still keep going, right? What else is going to change? 8. The 8 is going to come up, right? So I'm going to have 8 squared in the numerator. What else am I going to have in the numerator? X to the 11th power. There's two more things we can do and should do to simplify this one. Before I go there, we're okay with what changes we made on problem number 108. Eight squared, of course, is 64. What about the x's, though? I've got x to the 11th over x squared. Subtract them. What am I left with? Is that x to the 9th going to be the numerator or denominator? Numerator. X to the 9th over y cubed. So this is the final answer that I would expect here. 64x to the 9th over 5y cubed. Let me do problem number 84. M to the negative 30 over m to the negative 40. In fact, why don't you try problem number 84? There's a couple ways we can do it. I'm curious as to which way resonates with you more. McKenna, how did you start this one off? Okay. Now, subtracting them, that's a little bit of a surprise to me. That was the way it was going to show. So you're on the same wavelength than I am. One thing you can do is subtract the exponents. What you have to be careful of is that you're subtracting a negative 40. And that double negative becomes a positive. So we get m to the 10th. So nothing wrong with it that way. I suspect a few others of you did it a little differently. What else could you do here? All right. Flip them and make them positive. And then 40 minus 30 is what? It's 10 again. So just curious, who likes method A? A couple of you. Method B. Okay. Guess what? You're all free to do what you want. All right. Both of them work, and it's just whatever you're most comfortable with. Speaking of comfort level, are you pretty comfortable with the problems here that we've done in section 5.2? Getting all right there? Want a couple more? Let's try 102. Let's see. Sorry, I was on the wrong page. Let's try 100 and 106. Probably 104 as well. So 100 is x to the 4th over 3 to the negative 4th. I wrote 102. 104. A lot going on in that one. S to the 2nd, t to the negative 8th, over s to the negative 9, t to the 2nd, all raised to the 4th power. That's a x to the 4th over 3 raised to the negative 4th power. Thank you. Help each other out on this one. Compare answers, see how you do. appreciate it. Chit chat around, turn to somebody next to you, compare your answers, see how you look. Madison, and back. What's a good way to start this one? What, the exponents? Okay, so, all right, so took the reciprocal on the inside, that's fine. 3 over x to the 4th, and the exponent on the outside, is that going to add or divide, or what's going to do to the exponents on the inside? It's going to multiply. Even though it's not really written, it's understood that there's a 1 here, so I get 3 to the 4th power over x to the 16th power, multiplying each by 4. 3 to the 4th power is 81. So 81 over 16 is what I expect for problem number 100. Now, it's interesting, Madison, you mentioned multiplying. You could multiply these exponents by -4. I would get x to the -16th over 3 to the -4th. Then I could play my little switcheroo game, and I'd be back to where I ended up anyways. Here and then here. I like making these exponents positive. I think it makes it easier. You guys make a lot less mistakes when you're working with positive numbers than you do negative numbers. So that's the way we'll start out. Problem number 104 is in the parentheses, I'm going to get rid of the negative exponents. That means bringing the s to the -9th up to the numerator. What other change is that going to require us to do? Yeah, make it positive, bring it up there. T to the -8th goes down to the denominator. So I get s to the 2nd, s to the 9th over t to the 2nd, t to the 8th, raised to the 4th power. Okay. So when we multiply things with the same base, you add their exponents. I get s to the 11th over t to the 10th raised to the 4th power. Last but not least, power to a power. Those exponents multiply. 4 times 11, 4 times 10. S to the 44th over t to the 40th. Yay. For homework, section 5.2. Try problems 13 through 75 and 81 through 111. There's also problem number 121 that would be of interest to you as well. If you'd like, we can do problem number 122. No takers? Okay. All right.